Let's continue the review. Let's see number 18. Yesterday we did number 17, adding two decimals. Now let's see number 18. Number 18 is a subtraction of two decimals. Number 18. We are using 5.69 to minus 2.335. Subtract a decimal from another decimal. We are going to align them vertically, right? Make sure the decimal separator are aligned. We put a 5.69 on the top, 2.335 on the bottom. So we are process a subtraction. Make sure when we line them up vertically, the decimal point is aligned. Yeah. The first decimal on the right-hand side, we only have two non-zero digits. The thousandth is has no number, right? So we want to put a zero here to hold a place. I'm going to color them. This is a thousandth. This is hundredth. This is tenth decimal point, and this one is once. Let's see. Look at the purple column. We want to use 0 to minus 1, 0 to minus 5, but 0 is less than 5, right? So we need to borrow. Yeah, we need to borrow 1 from the 9 in the orange column. So the 9 will become 8. And 0 will become 10. It will become to 10, right? So first again. Yeah. So when the 0 become to 10, we can use 10 to minus 5. We have 5 here. Yeah, the orange column, 9 became 8. We use 8 to minus 3. Do we have a 5? Yeah. Let's see the green column. 6 minus 3. Let's bring down the decimal point. The yellow column, once, 5 minus 2. And the difference of the two decimals is 3.355. Does that make sense? Yeah. That's how we process subtraction, okay? Yeah. Do you think you can do this without using calculator? Pretty much. Okay. Number 19. Number 19 is a multiplication of two decimals. I'm gonna give you 1 minute, and you guys try on your own first, pretending you are taking the test, to see if you can get it right. Number 19, 2.8 times 8.1. If you look at the 2.8, the number is pretty close to 3, right? The blue number, the blue decimal, pretty close to 3. And 8.1 is pretty close to 8, right? 3 times 8, what is 3 times 8? 3 times 8. 24, yeah. Your result should be a number around to 24, not far away from 24. Okay, yeah, take your time. Let's see how do we multiply the two decimals. Yeah, you can look at your note. What's the rule when we multiply two decimals? How do we line them up? We will not have a calculator on Monday, so try to see if you can figure it out on your own. So what is this? Big times, right? Oh, your multiplication table. Okay, okay. Yeah. I actually can give you the multiplication table on the text. Yeah. That helps. Yeah, the number you got should be not far away from 24. Let's see. Remember, we have two methods to multiply decimals, right? And the first method is we're gonna align the two decimals vertically. Make sure the last non-zero digits are aligned. 8 and 1 in this case are aligned, right? And then we're gonna ignore the decimal separator. Multiply 28 by 81 as usual. Yeah, multiply the two whole numbers. 1 times a is a, 1 times 2 is 2. 8 times a is 64. 2 times a is 16. 16 plus 6 is 22, right? So we have 22 here. And we add them up. We have 8 here, 6 here, 22 here, right? Do you have the same thing? Okay. And we're gonna put in here. Make sure 8 is here. 6, 2, 2. How do we place the decimal point? Since we have one digit, one non-zero digit to the right of the decimal point for the first decimal, and also one digit to the right of the decimal point for the second decimal. 1 plus 1 is 2, right? So we should move the decimal point to the left 1, 2, 2 times. The answer is supposed to be 22.68. It is pretty close to 24, right? Yeah, does that make sense? Yeah, on the test, I can give you the multiplication table. That's okay if that helps. Another method. Let me show you another method. When we multiply 2.8 by 8.1, we can rewrite 2.8 as 28 over 10, right? We can write 8.1 as 81 over 10. As fractions, we multiply them together. We have 28 times 81 in the numerator. Denominator, 10 times 10 is 100. The numerator, we still have to know what is 28 times 81. We got a 2,268. Divide a number by 100 is equivalent to move the decimal point to the left 2 places. And we end up with 22.68 as well. Yeah, multiplication of decimals. Any questions? Let's see number 20, division. Number 20, we're going to divide 74.7 by 5. Question, in this division, which number is dividend? Which number is dividend? We have a dividend and a divisor in a quotient, in a division, right? Which number is dividend? Which number is divisor? Dividend, divisor. We need to know which number plays what role. Which number is dividend? This number is dividend, okay? Yeah, dividend. And this number is divisor. All right, and we need to remember that. And when we apply long division to process division of decimals, remember we want a divisor as a whole number. Yeah, a while ago when we covered this part, the example, the divisor is not a whole number. We have a way to change the divisor as a whole number, right? But in this case, the divisor is already a whole number. Yeah, we don't have to really do anything because it's already a divisor. If it's not, for example, 8.102 divided by, let's say 5.4, right? Dividend is 8.102 in the numerator, divisor is 5.4 5.4 in the denominator. So in order to apply long division, we have to make the divisor as a whole number first. To do that, we move the decimal point in the divisor to the right one time. We're going to do the same thing to the numerator. Also move the decimal point to the right one time. And we have 81.02 over 54. Okay? Do you remember that? Yeah, in our case, it's easier because the divisor is already a whole number. So we can start the long division. I'll give you a minute. Can you do that first? Yeah. You want to put the dividend under the division symbol. Divisor as a whole number now to the left of the division symbol. I'll give you a little bit of time. And if you look at this decimal is 74.7 is close to 75, right? Yeah, very close to 75. What is 75 divided by 5? What is 75 divided by 5? Huh? Yeah, 15. Yeah, so you're gonna know your answer gonna close to 15, not too far away from 15. Would be a little bit less than 15 because the numerator, the dividend is a little less than 75. All the problem is gonna be multiple choice question. Yeah, those facts, your judgment can help you to eliminate some options, which is definitely wrong, to narrow your options. You have the answer already? What do you have? Guys, what do you have? 14.940. 14.94. Yeah, okay, let's see. So let's start from 7. Does the 5 go into 7? 5 is less than 7. 5 is less than 7. I mean, could a 5 go into 7 like at least one time? Yeah, so at least one time, at most one time as well, right? Because twice of 5 would be 10. 10 would be too big to fit in 7. So we have a 1 here. Right, everybody? Yeah. So when 5 go into 7 one time, the remainder would be 2, right? Yeah. Okay. So 2 is smaller than 5, so we're gonna bring down 4. Let's look at 24. Does the 5 go into 24? 5 is smaller than 24, so 5 should go into 24 at least one time, right? Actually, twice is okay. 3 times is okay. 4 times is also okay. 5 times is not okay. 5 times is 25 is bigger than 24. So, and the most 4 times. Yeah, 5 goes into 24 4 times. The remainder will be 4, right? You see that? And then we bring down the next digit. We have 47. Again, we're gonna start to find a quotient. How many times 5 go into 47? 9 times. Yeah, 9 times. What's the remainder? 2, right? But we don't stop here because we want to divide completely. So we have to bring down another digit. There's nothing in the dividend for us to bring down. So that's the reason we need to put a 0 here. We're going to put a 0 to hold a place. We will not change the value. So we're going to bring down 0 here. Okay? So we have 20. How many times the 5 goes into 20? 4 times. Very good. And the remainder is 0 now, right? Yeah, as the remainder is 0 for the long division is complete. Let's look at the quotient. The quotient is not 1,494. Instead, you have to place the decimal point between 4 and 9, right? The correct answer is 14.94. It is pretty close to 15. Yeah, a little bit shy, a little bit less than 15. Any questions? The long division for the divided decimals. divided decimals. That is number 20. All right. You can see it's not very challenging, right? Yeah, I don't challenging you. Don't or surprise you. The problem in the test on Monday would be very similar with those problems. It will be a good idea for you to repeat the sample examples at least 5 times. Let's see, 21. 21, you are given an inequality. Let me explain what is inequality. We know what is equation, right? If you see an equal sign in an expression, that is an equation. An inequality is you see one or more of inequality symbols. Yeah, we have the following 5, but actually we only do 4 inequality symbol. This one or this or this or this or this. Okay, this is called greater than or bigger than. Strictly bigger than. This is a strictly less than. Yes, strictly less than. This is a no less than or at least bigger than or equal to, right? For example, at least 5 is you have no less than 5. At least 5. And less than or equal to here is at the most or no more than. The maximum is a number here, right here. And this is not equal to, but we don't really handle that inequality much. So mainly is the 4 inequality symbol. So if we see one or more inequality symbols in a given expression, then that is an inequality. Okay, yeah. Inequality also has a left-hand side and a right-hand side. In a given inequality in this problem, the left-hand side is this green part. The right-hand side is this green part, right? We need to determine if the left-hand side really no less than the right-hand side. If the given inequality is a true statement or false statement. Yeah, if you have 1 greater than 0, that is a true statement, right? Because 1 is greater than 0. But if you have -1 bigger than 0, that would be a false statement, right? Yeah, so we need to determine if the given inequality is a true statement or false statement. So how do we process this? How should we start? How should we start? How do we know if the left-hand side greater than or equal to 21? 21 is a constant. Isn't the left-hand side too complicated, guys? Yes? Okay, I give you 1 minute. You help me to simplify the left-hand side. The left-hand side is 4 times bracket. Inside the bracket, we have 6 plus parentheses. Inside the parentheses, we have 5 minus 6. Yeah, please take time to simplify this expression and let me know what's the value. We learned 3 rules for correct order of operations, right? The first rule is please excuse my young study. The second rule is when we only have a multiplication division, we go from the left to the right. Third rule is if we only have addition and subtraction, we go from the left to the right. How many grouping symbols do we have in this expression? How many sets? Huh? How many sets grouping symbols do we have? 2, yeah. We see bracket, right? Inside the bracket, we have a parentheses. Then which grouping symbol should we handle first? Parentheses, exactly, yeah, please do that. Evaluate the quantity in the parentheses first. What is 5 minus 6? Perfect, yeah. And then you evaluate the stuff inside the bracket. What do you have? You told me this is 91. That's correct. And what's in the bracket? 6 plus 91, right? What is it? 5, exactly. So that is 4 times 5, right? Yeah, what's the answer? 20. So the original inequality is 20 greater than or equal to 21. What do you think? 20 greater than or equal to 21. Is that true or false? Of course, false, right? Of course, it's a false statement. So you're going to choose false. Does that make sense? Yeah. Let's suppose, of course, we are done with this problem, right? I'm just saying, suppose you have 21 greater than or equal to 21. Is that true statement or contradiction? Suppose, like, has nothing to do with the given inequality anymore. I'm just saying, suppose you have this inequality. Is that true or false? True. 21 is no less than itself. What if the inequality is 21 greater than 21? Is that true or false? 21 is strictly greater than 21. Is that true or false? False. Do you agree? It is false. Yeah, the number is not bigger than itself. Okay? Yeah, this is a false. This is a true. Okay, so you need to be careful. Any question about number 21? Let's see number 22. Yeah, for understanding number 22, let's do a practice for real numbers. Yeah, for real numbers. If we have two factors, if we consider multiplication, yeah, in the multiplication we have two factors, x and y. If x and y are both positive, then the product, of course, is positive, right? If both of the two factors are negative, both are negative, then the product is positive as well, right? If the two factors have an opposite sign, one is positive, the other is negative, like this, then the product is negative, right? So we need to remember, for multiplication, if the two factors have the same sign, either both positive or both negative, then the product is positive. If the factors in the multiplication have an opposite sign, one is positive, the other is negative, then the multiplication is negative. All right? Okay, that would be enough for us to determine, to make a decision in number 22. Let's see what's in number 22. We know A is positive, is given, okay? There's no y, it's given, A is positive. B is positive. C is negative. Yeah, that's the given conditions. Based on those conditions, we need to determine, is this guy, A times B times C squared, positive or negative? Okay, I give you 1 minute and you tell me what you think. We need to know the sign for the product. In the product, we have A times B times C squared. Yeah. We need to know, we need to determine that positive or negative. Yeah, it's positive. Okay, you got it. Can you explain why it's positive? Why is it positive? Can you tell me C squared? Is C squared positive or negative? Why C squared is C is negative? How come C squared is positive? C is negative. What about C squared? Yeah, you're right. Yeah, don't doubt yourself. You're right. Yeah, C squared is C times C. C is negative, right? But that doesn't matter. C is negative. C is negative. Negative times negative. You have positive, right? So square would never be negative. Do you agree? A perfect square will never be negative. At least it has to be 0. 0 square is 0. For any other non-zero quantity, their square always is positive. Does that make sense? Because even the number C is negative, but its square is C times C. a negative number times a negative number will give you a positive number, right? Right? Okay. Yeah, so here you see this is a positive. This is a positive that is given. A is also positive. So in this product, all the factors, all the three parts are positive, right? Of course, the product is positive as well. Does that make any sense? Is that clear? Everybody? Angela, is that clear? Okay, very good. Perfect. Of course, in the test on Monday, maybe the problem a little bit different. So you have to be careful, okay? Yeah, you need to determine based on the given condition. Maybe on Monday, the B is less than 0, okay? So you need to know the answer will be different. Yeah. All right, let's see number 23. Number 23 is to simplify this expression. So you can see this is about the order of operations, right? Yeah, you can see in this expression we have parentheses, we have square, we have addition, yeah, we have multiplication. I'll give you a couple of minutes. Can you work on this problem on your own first? Let's see, what do you have to simplify after you simplify the expression? The rule you want to consider, we have 3 rules. Yeah, the first rule is please excuse my dear Aunt Sally. P stands for parentheses, means the grouping symbol. Please excuse my dear Aunt Sally. Parentheses first, yeah. Grouping symbol first. Let me know if you need help. And not only we need to know the correct order of operations, but also we need to know how to compute those numbers manually without a calculator. If it's necessary, try to use the real number line, help you to see. Oh, I'm sorry. 4 times 6. That's not a 4.6. I apologize. Let me make it clear here. Sorry. This is 11 minus 4 times 6. The dot is in between, not on the bottom. It's not 4.6. It's 4 times 6. Okay. Sorry about that. 4 times 6. During the test, if you have anything like not very clear, not very certain, just ask me. What do you have? 24? Okay, let me see. Also, this is 9 times 7, not a 9.7. It's a multiply. Yeah, I can write it as this symbol. Okay. Yeah, let's see. Please excuse my dear Aunt Sally. How about let's process whatever in the parentheses first. In the parentheses, we have subtraction and multiplication. Should we go subtraction first or multiplication first? Yeah. What is 4 times 6? 24. What is 11? What is 11 minus 24? 13 positive? Yeah, negative 13. Yeah, negative 13. So here, plus negative 13 actually means minus 13, right? Minus 13. And then we see exponentiation. What's 10 squared? And we see multiplication. What is 9 times 7? And then minus. Yeah, now in this expression, 100 plus 63 minus 13, we only have addition and subtraction, right? Rule number 3, if the expression only contains addition and subtraction, we go from the left to the right. We go from the left to the right, okay? 100 plus 63, 163, and then minus 13, 150, right? Yeah. Yeah, so I want you to check your result to make sure you have the same thing. Yeah, let me double check. 100 plus 63 minus 13. Yeah. So can you look at your solution? You get the same thing? Okay, very good. Okay. That's number 23. 24. Evaluate expression for given for the value for the given value for the variables. Yeah, this problem is very similar with an example that we have seen. The expression is 9x squared minus 4y with two variables, variable x and a variable y. We don't know the values, right? So when the value of x and y are not certain, the value of the expression is not certain. What we need to do is to find a value for x equals 3, y equals -4. And now the problem tells us, let x be 3, y be -4. Let's see how do we do that. I'll give you a couple of minutes. Please try on your own first. You might remember the process when I handle this kind of problem. I always use the parentheses to hold the place first. I don't rush to plug in, especially when the value is negative. I do not rush to plug in. I use parentheses. Yeah, -4. When you plug in y equals -4, so you should have a -4 times -4, right? Be careful with the sign. Yeah, exactly. Perfect. Very close now. So remember, please excuse my setting. So you're gonna do the exponentiation first, right? Right? Yeah, and then you multiply 9. 3 squared. Here. And you see I have those. You're gonna be able to see them in the test. 3 squared. Right? 3 squared is 9. And 9 times 9 is on the board as well. 9 times 9 is right here. 9 squared. 9 times 9 is 9 squared, right? Right here. Yeah. So should you process the multiplication first? What is it? So which two factors in the multiplication? Are you multiplying -4 by -4? Yes, yeah. So let's determine the sign first. Negative times negative, do you have negative or positive? Yeah, positive, of course. We did that earlier, right? If the two factors have the same sign, the product is positive. And what should you have? Yeah. Yeah, exactly. Why do you have a negative? Yeah, be very careful. Perfect, very close, very close. Where do you get that? Yeah, that's 3. No, just be careful. We learn algebra, yeah. So doesn't that look like a 3? Sometimes, yeah, I think that's a permanent 3. X equals 3. What is that? It's just the same. Okay, okay, perfect. Yeah, perfect. That's good. Remember, please excuse my de-understanding. Is exponentiation before multiplication, right? So in this expression, we have 9 times 3 squared. Should we process the square and then process the multiplication? So when we process the square, 3 squared, what should we have? 3 squared, yeah. 3 squared is 9, yeah. So you have 9 times 9 here. This part is perfect. 24 times 24 is 16. Oh, very good. 81, yeah, 81, perfect. So do you see that? Yeah. Please excuse my de-understanding, right? So exponentiation before multiplication. Do you have an answer? Good job, very good. Do you have an answer? Perfect. Let's see this problem together. All right, you see, I would use a parenthesis to hold the place first. Right, that's what I do. Yeah, and then I'm gonna put the numbers in the parentheses. Yeah, the first parenthesis was for x. We know x is 3, so I'm gonna put a 3 here, right? Second parenthesis, hold a place for y. We know the value of y is -4, so we're gonna put a -4 here, right? Okay, now we're gonna think what's the correct order of operations. Please excuse my de-understanding, right? Yeah, please excuse my de-understanding. E here means exponentiation. We should process exponentiation before multiplication, right? So we should process this part first. This part first. What is 3 squared? 9. So we have a 9 times 9. That's not 9.9. Okay, the 9 times 9, and then we have a multiplication here, right? Yeah, we can just we can maybe copy the here -4 times -4, and in this expression we have a multiplication, subtraction, multiplication, right? Multiplication go before subtraction. Let's see what is 9 times 9. 81. Very good. And then let's see what is -4 times -4. Negative times negative is positive, right? Yeah, so we know, okay, that product is positive, and 4 times 4 is 16. And then we process this addition, we have a 97. All right, this is a very good problem, very basic. Yeah, I would recommend use the parentheses, Yeah, that's number 24. Number 25 through number 29 are those 5 problems, okay? Yeah, we're gonna leave that after number 30. Let's look at number 30. Simplify by combining like terms. Simplify by combining like terms. Let's see this expression. We have a 5x plus 4x plus 2x minus 7x. I give you 1 minute. 5x plus 4x plus 2x minus 7x. the last topic, the last section of this chapter is simplifying expression. We learned two important concepts. Okay, what is a term? What is the like terms? How do we combine like terms, right? So this problem is about that part. Is it 5x? How do we understand 5x? That's 5x, right? And what is 4x? 2, 3, 4. And what is 2x? That means 2x, right? 2x, yeah. And then suddenly minus 7x. So 1, 2, 3, 4, 5, 6, 7. Yeah, so we're gonna remove 7x. So 1, 2, 3, 4, 5, 6, 7. So what should you have? 4x, right? Does that make sense? Yeah, like terms. What's the definition of like terms? The terms whose variable parts are exactly the same, right? Yeah. Look at this expression. How many terms do we have? How many terms do we have? 4. Yeah. Also, terms can be understood as parts in an expression separated by plus minus. You know. So you see, we have 4 terms here. Are they all like terms? Look at their variable parts. Yeah, their variable parts are exactly the same, right? It's just x. Yeah, so they are like terms. When we combine like terms, we combine their coefficients. Coefficient 5, 4, 2, -7. We add them up. We have 4, right? So the answer is 4x. Yeah, more specific, like what I showed you earlier. 5x means 5 times x. Like you have 5x here, right? And 4x means you have 4x x's, yeah, plural. And 2x, you have 2x. Negative 7x, you're gonna remove 7x from those x, right? And you have 4 left. Maybe this is better. Yeah, that's the most, that's the essence actually. Okay, as I mentioned, number 25 through number 29, 1, 2, 3, 4, 5, the 5 problems are about properties of real numbers. Let me show you this package we went over yesterday, and I wanna know if you guys still able to find the correct answer for them. Let's see, number 1, commutative property. Which one describes commutative property? This is the second time we go over this package, the 5 problems. Which one? B, exactly. Because in D, 7 plus 1 and 8, they are interchangeable, right? So if I color them different, this is a blue, hold on. This is a blue, blue, green, green, yeah. Part D tells us the green part and the blue part are interchangeable in the addition. So that is an example for commutative property of addition, right? What's wrong with A? A is what property? Is it 0 in the addition? 0 in an addition. Yeah, what if I slightly change the problem? What if I slightly change those problems? Would you still be able to get a correct answer? A here is identity, right? 0 is an additive identity, right? Yeah. B here is not a false, it's not a true statement, it's a false statement. So if the equation itself is false, just get rid of it. C here is a commutative, C here is associative property. Okay, 7, 1, 8, 7, 1, 8, 7 plus 1 first, here 1 plus 8 first. And you need to be able to see all the answer choices. What if I slightly change the problem? You need to still know how to do that, okay? Yeah. Part number 2, which option describes associative property? Tell me. Which one? Associated property. Associated property. Number 2. Associated property. Associated property involves 3 quantities. Which one is that? D is not a true statement. D is in dog. Left hand side is 14, right hand side is 10. You get rid of the D first. Yeah, thank you, Lauren. Do you guys see that? A, 3, 4, 7, 3, 4, 7, 3 and 4 associated together first. On the right hand side, 4 and 7 associated together first, right? See that? And what happened to C? C is identity again, additive identity. B, commutative because 3 plus 4, 4 plus 3, right? Do you guys see that? Yeah, again, I tell you, the problem is gonna be super similar with those 5 problems, but maybe I will change a little bit. Then you need to still know how to choose the correct answer, okay? Number 3, inverse property. Number 3, inverse property. Which answer choices is an expression, is an example for inverse property? Let's recall how many how many inverses do we have? 2, yeah, one is the additive inverse, right? Or the inverse in addition. The other is a multiplicative inverse. Yeah, inverse in multiplication. Yeah. How do we understand the additive inverse? We have another name for it. Yeah, additive inverse. At the beginning, the pronunciation is pretty challenging for me. Additive inverse. Do we have a name for that? A different name for that? Additive inverse. Opposites. Opposites. Remember that? Yeah, opposites. Additive inverse. Another name is the opposite, okay? Yeah, what about multiplicative inverse? Reciprocal, great, yeah. All right, let's see number 3. Which one is an example for inverse property? Maybe additive inverse, maybe multiplicative inverse. Let's look at the A first. Is A a true statement or false statement? True, false statement, right? It's a false statement because the left-hand side equals what? You tell me. We learned the fractions. Negative, negative, multiple positive. Yeah, you see that? Vertical, vertical, diagonal, diagonal. Yeah, or in other words, do you see these 2 guys? Negative 9/2, negative 2/9, they are reciprocal of each other. Shouldn't they multiply to 1 if they are reciprocal? They shouldn't multiply to 0, right? Yeah, so this is a false statement itself. Of course, you don't choose that. Then part B, yeah, part B. The 2 numbers add up to 0. However, when you look at closer, the 2 numbers are not really opposites. Kind of confusing, right? Kind of like tricky. Because one is a positive, the other is a negative. However, they do not have the same absolute value. 2 numbers are opposites, means they have an opposite sign, and they have exactly the same absolute value. They do not have same absolute value. This is 9/2. This is 2/9. They are not the same, right? So they do not add up to 0. They do not add up to 0. Do you guys see that? So you can just eliminate this option. Let's see C. Look at the 2 numbers. Negative 9/2. Negative 2/9. Do you see the 2 numbers are, what is that? Are they, flipped? Are they reciprocal? Yes, yeah. Negative 9/2, negative 2/9. They are reciprocal of each other. So they are multiplicative inverse of each other. They multiply to 1. You see that? Yeah, important thing is you won't have a calculator. You will have to determine on your own. Part D, what's wrong with part D? Okay, let's see the left-hand side. Negative times negative is positive, right? 9/2 times 9/2. Shouldn't we have 81/4? That would not be 1, right? Yeah, so be careful, be careful. Actually, it's easy to eliminate the D, B, and A because they are all false. C here, in number 3, C here is the only true statement. And it does describe the inverse property. Let's move to number 4. Identity property. How many identities do we have? 2, yeah. Additive identity. What's additive identity? Yeah, the identity in addition. What number that is? 0, awesome. What's the multiplicative identity? 1, okay, perfect. Let's see. Part A, even is a true statement. However, it's a multiplication, right? Yeah, the multiplicative identity is supposed to be 1, so this is not. Even the statement, even the equation is a true statement, we do not choose that. Am I clear? Let's see part B. 2x plus 0 equals 2x. Addition, additive identity. Does that show 0 does not contribute in addition? Yeah, B as in boy. B is the correct answer for this problem. What happened to C? C is a false statement. Do you see that? Left-hand side multiplied by 0 is 0. It won't be 2x anymore. B, 2x minus 2x equals 0. The statement, the equation is true. However, it actually shows the inverse property. Why is the inverse property? Because 2x, negative 2x are opposites. They add up to 0. 0 is the additive identity. So part D is more like an inverse property, right? Two numbers are opposites, they add up to 0. So that's the reason for number 4, we choose B as in boy. Number 5, distributable property. Yeah, which one describes distributable property? We apply distributable property to remove parentheses. Look at A and C. Look at A and C. Right-hand side still have a parentheses, right? That means at least they didn't apply the distributable property thoroughly. And what happened to B and D? B is a false statement because the left-hand side is negative, right-hand is positive, right? So the only possibility is B as in boy. You can see coefficient of the parentheses is -5, right? Once you remove the parentheses, you have a -5 times x, -5 times y. Do you see that? Repetition make it perfect. I would recommend you during the weekend, repeat each sample example in the review 5 times. I would expect everybody do a great job on Monday. Okay, if you repeat enough, you will. Thank you guys. I'll see you on Monday.